Hello, my name is Steve Bird. I'm the team lead for the Economic and Policy Assessment Group at the Institute for Transportation Research and Education at North Carolina State University. I will be providing a demonstration of the cost tool that we developed as part of NCDOT Research Project 2020-44, with the goal to better estimate the comprehensive cost of rail incidents in North Carolina. The cost tool accompanies a research report, The Comprehensive Cost of Rail Incidents in North Carolina. The report documents the methodologies used to appraise the various cost elements that are born from railroad incidents. In addition, the report provides an estimate of railroad costs over the last decade in North Carolina, with a detailed accounting of costs for year 2019. The cost tool that I will be demonstrating was used to estimate the values found in this report. I will be demonstrating how to estimate first an emergency responder costs resulting from rail incidents. Emergency responder costs begin with a first responder unit being dispatched to the scene of an incident. Costs can then increase notably if police, paramedics, medical evacuation helicopters, fire suppression, or hazmat cleanup teams are needed to address a rail incident. For this study, North Carolina's public safety answering points provided information to monetize emergency responder costs. A total of 246 timestamps provided in computer-aided dispatch records for personnel and vehicles responding to an incident were used. This information was used in conjunction with phone interviews, email correspondence, and findings from a literature and data review to estimate first responder costs. Now that you've been briefed on emergency responder costs, let's demonstrate how the tool works. First, and emergency responder costs are estimated using part 4 of the tool with the brown color designation. The tool can be used to estimate emergency personnel and equipment costs associated with a rail incident. The magnitude of a rail event directly impacts the emergency response costs resulting from a rail incident. Thus, it is important for you to determine the level of impact of the rail incident before using this part of the tool. Rail incidents are defined in 4 categories: low, medium, high, and very high impact events. In low impact events, no injuries or fatalities are reported or anticipated. The train, its crew, and any passengers are minimally affected by the incident. The incident may include brush or spot fires, a non-vehicle object struck on the tracks, a vehicular crash with a positive identification of no one in the vehicle, first response, or other incidents expected to have a minimal property damage outcome. Medium impact events. Based on 911 caller information, the rail event could result in injuries, or the magnitude of the event is unknown and thus requires a robust emergency response. This may include events such as derailments, train-to-vehicle collisions, train fires, or other incidents expected to have property damage outcomes that could result in injuries. High impact events. Based on 911 caller information, the rail event is likely to result in injuries or fatalities. This could include a derailment, a collision, a pedestrian strike, a vehicle strike, an explosion or detonation, a hazmat spill, or other incidents that are likely to result in significant property damage and likely injuries or fatalities. This type of event results in high levels of emergency personnel being sent to the scene. A very high impact event goes above and beyond a high impact event. Catastrophic injuries or fatalities are reported or anticipated. An example of a catastrophic event includes the 1986 collision between an Amtrak passenger train and 3 Conrail locomotives. During this event, 400 victims were assessed at secondary triage. 177 were transported to 11 hospitals and 22 were admitted. A total of 37 fire and rescue department vehicles and 7 private ambulances transported the casualties. A very high impact event results in very high levels of emergency personnel being sent to the scene. Let's demonstrate how the tool works. We're going to evaluate emergency responder costs associated with a medium impact incident. This is a freight train derailment with multiple cars derailed in this hypothetical scenario. Now we are going to take inventory of the type of first and emergency responders involved. We've learned that 2 law enforcement and 1 highway safety patrol unit are sent with 2 people in each unit. This is 3 units with 2 in each, total of 6 personnel. EMS have also been dispatched to the scene with 2 people. The fire department has dispatched 2 personnel in a quick response vehicle. Now we're going to take inventory on the amount of time units were involved in addressing the incident, from dispatch to close. In this instance, we do not actually have the information for time involved, so we're going to use the tool's expected values. We're going to use the mean, or the average amount of time spent addressing an incident. We're also going to use the tool's expected values for personal time costs. We're going to use the median values for time costs. Next, I'm going to input information for the equipment involved to estimate associated equipment costs with the rail incident. If you remember, we have 2 law enforcement and 1 highway safety patrol units, or a total of 3 squad cars. We have 1 EMS unit that has been dispatched. And we have 1 quick response vehicle. A quick response vehicle falls into the all other vehicles category. We're going to use the mean expected time costs for equipment being on the scene. We're going to use the medium expected values for vehicle operating costs per minute. Now we can see using the tool that our emergency personnel costs have accrued, as well as the equipment costs associated with attending to this event.